Let's take a look at number 30. This is section 7.2, number 30. What we are asked to find is, a little proposition here. We've got congruent circles, or the same circle, and I have two chords that are congruent. In this case, it's chord AB and chord CD. What we need to show is that the chord's central angles, that is to say these angles that they make from endpoints to the center, are congruent. So we need to show AOB is congruent to CPD. And we know AB is congruent to CD, circle O is congruent to circle P. I set it up like this, with two circles as opposed to the one circle. I think it's easier to visualize that way. So let's get proving. Proof. Segment AB is congruent to segment CD. We were given that. Next, I'm going to say that implies that arc AB is congruent to arc CD. Why? Well, we were asked to prove it in problem 27. That means because these arcs are congruent, the angles are congruent. Congruent arcs means congruent angles. So the definition of arcs and measurements. And we're done. Except, this. This is kind of a sore thumb of a reason here. We didn't actually show number 27. So this was just a claim. Let's prove it. Let's prove that claim. Let's do number 27 as well. And in 27, what we need to show is that if you have two congruent chords, they have congruent arcs. So we've got something like a circle here with AB, and that's congruent with CD, and we need to show AB is congruent to CD, the arcs. Okay, to do that, I actually want to get a little creative here. Rather than just these little simple things here, we're going to draw the radii OA and OB, CP, CD. Now, circle O is congruent to circle P. Means they have the same length. That implies that they have the same radius. OA is congruent to OB, is congruent to CP, is congruent to DP. And we already knew that AB is congruent to CD. So that means that triangle AOB is congruent to triangle CPD by side, 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 which means that angle AOB is congruent to angle CPD by corresponding parts of congruent triangles are congruent. And then that means that arc AB is congruent to arc CD by the definition of an arc, how long arcs are. Last problem here, number 31. Similar to but distinct from 30. In 30 we were told, hey, these chords are congruent. Show me that the angles are congruent. In 31, we're said, hey, we've got some congruent central angles. Can we show that that means that AB is congruent to CD? Well, can we show that the arcs are congruent given these two distinct central angles that are congruent? Sure. Take a look at what we did previously. We drew some triangles. We're going to do that again. We're starting in a different place. We don't have any congruent chords here. So we can't just directly invoke what we did previously. Let's draw some chords though. Let's draw A, B, C, D. I'm just going to freehand it here. A, B, C, D. Next, we know that AO is congruent to CP because the radii is congruent to BO is congruent to DP. These guys are all congruent because the circles are congruent. Remember, congruent means same length. These circles are congruent, that means their radius is the same length. All radii are the same length, so all four of these lines are the same. More importantly than any of this, oh, it's all the same, is that I can pick off one pair, two pairs of congruent parts, and they have a congruent angle in between them that we were given, AOB, CPD. That was part of this theorem. We have a congruent central angle, or excuse me, congruent central angles. And this was given. So that means that triangle AOB is congruent to triangle CPD by side angle side, which means that length AB, that side is congruent to the side CD by corresponding parts, which means that from our previous work, two congruent chords, they've got congruent arcs. Always use previous work when you can. And that's that. Alright, this was geometry. Thanks for watching. See you next time.